Welcome to the Inspire range. The Inspire Dynamics cars have a full range of accessories for dynamics experiments. Elastic bumpers, inelastic Velcro bumpers, hook attachments, an explosion bumper and hammer, additional masses for either car, large hooks for the track end plate, a pulley attachment for Newton's second law, masses, hanger and cotton cord, a large bumper and double-sided tape for crumple zone experiments, elastic bands and cord for oscillations, a linear track and a curved track. Each car has spring-loaded, low-friction wheels, magnets for attaching accessories such as bumpers and hooks. The primary car is marked with P and the secondary with S. The pegs are locations for additional masses. The primary car communicates wirelessly with a PC using Bluetooth. Infrared sensors provide communication between the cars. Elastic bumpers are fitted to both cars and to the end plates of the track. Both cars are switched on. The blue LEDs flash. The cars are connected to Timing Pro software. Click on Start Stop to begin the experiment. The blue LEDs become steady. Push the primary car so it collides with the secondary car. Data is plotted in red and blue on the default graphs in real time. Primary data has red headings, secondary data has blue. Data before and after collision can be deleted, or the user can zoom in on the useful part of the graph. Select graphs by clicking on the icons. We can remove displacement, we can remove acceleration and select momentum and energy. Using summation, we can show that momentum is conserved and energy is conserved. Using the large bumper, aluminium foil and double-sided tape, a crumple zone can be made. This is intended to absorb some of the energy of a collision. Look at the data, in particular the energy graph. Zoom in on the collision. Use summation to see whether energy was conserved. Clearly, it is not. The cursor can be used to find instantaneous values of energy before and after the collision. Approximately half the primary car's energy was absorbed by the crumple zone. This standard experiment uses the primary car alone to investigate potential and kinetic energy on an inclined plane. The linear track has a special block to raise one end. The track has a simple clinometer built in. The angle is entered in the software. The car is connected to the software. Clicking Start Stop begins the experiment. The user is prompted to move the car from the bottom to the top of the track, giving it some initial potential energy. Releasing the car allows it to roll down the slope, losing potential energy and gaining kinetic energy. We can see velocity increasing, and we can see two plots for energy. Looking more closely, we can see kinetic energy increasing and potential energy decreasing. Using the summation function, we can see that energy is conserved. Timing Pro software has a dedicated procedure for Newton's second law. A falling mass makes the primary car accelerate. Varying that mass and the mass of the car provides data to verify Newton's law. The primary car is used alone for this experiment. Connect the car to the PC, click Start Stop, then release the car from one end of the track. From the software, it is possible to measure the period of the oscillation. Run the experiment again with the car fully loaded with additional masses. Measure the period of the oscillation again. How does this relate to the motion of a simple pendulum? Oscillations can also be studied on the linear track. The primary car is used alone. Two strings of elastic bands are required and the hook attachments at the end of the track. Both chains of elastic bands are fixed to the car. With the car connected to the software, click Start Stop and displace the car either to the left or the right. Measure the period of oscillation from the software. Then repeat the experiment with the car loaded with additional masses. The oscillation appears slower. The software will tell you how much slower. Why is this different from the changing mass of a pendulum? Dynamics cars are one member of the Inspire family of products.